Bresenhams algorithm. Well, I thought it was going to take me a couple of hours to take the algorithm, which I already have working, and place it in the ROM as a subroutine. After all, I have done this before with a couple of other subroutines. So all we need to do is take the colour and the position information, push it onto the stack, then within the subroutine, pop those values off the stack and save them as local variables within that subroutine. And then we can mess about with them within the subroutine, and we can draw the line, and we can leave the original variables as they were. Now, I thought this was going to take me a couple of hours on Monday, but here we are on Thursday afternoon, and I have just completed it. And it's not as if I've just been sitting about doing nothing. I've been at it for about 4 or 5 hours a day, every day for the last 4 days. And I'll show you the issues that I have, and I'll show you the way I solved them. Now, the first thing I'll do actually was I'll just show you working. So I have a piece of code here, and it's called line. So here's the line code here. So all we have is our origin 0x8000 for our line code. And we're going to push the x1, y1, x2 and y2 and also the colour onto the stack. We're going to call the subroutine line, so it's jumped to subroutine line. And then whenever it comes back from that subroutine, it doesn't return anything back, it just draws the line within the subroutine, and then it goes to this end command. And all we have here really are the initial values which I've set up for our x1, y1, x2, y2, which are these values here. So again, these would just be placed somewhere within memory, and we could go and get them and then push them onto the stack and use them to draw the lines. Now the final one here would be the colour, so we can adjust the colour here, and this value here for line for our subroutine is just the position within the ROM that I have saved the subroutine. So that's a little program here, and I can compile it, assemble it and generate the machine code, and I'll go in just now and I'll load it up. Okay, now it's just drawing a line in white, but of course you can have any colour that you want. And I'll actually do it real time because although it's slow, it's not that slow. Let's see, make sure it's on at full speed. It is. So first of all, I draw a little dot in the centre. It's just so that we know that that position there is the centre of our screen. And of course, I've not mentioned it here, but I've set it out so that you can work from the centre of the screen. So rather than working from the top left hand corner as the origin, now the origin is the centre of the screen. So whenever I go left, we're going minus, and right is positive, up is positive and down is negative. And you can see here, it started drawing the lines out here. And this is how long it takes to draw out a line. But again, we're not bothered too much about the speed, as long as it actually works and we can see it working. So it'll take about, I don't know, about 20-30 seconds, 40 seconds to draw out the line. And there's only 7 pixels in this line here. So that's it, just about done. And this is our little line, and I've shown you before, I won't show you it here. I can actually run up the simulation tool, and you can see that every single pixel matches with the pixels that we expect to get, and you can see here it has actually finished. So that's us able to draw a line using the Bresenhams algorithm. The algorithm is a subroutine within the ROM. So I'll stop this just now, and I'll quickly go over a couple of points that were preventing me from doing this, and it's why it's taken me 4 days to do instead of 2 hours. Now the main problem that I have, and I couldn't get to the bottom of, was a little kind of blip. Now the blip here is in the graphics card, and I've had this kind of blip before, and I've just had to try and find ways round about it. So within the graphics card here, what was happening is I was getting some random changes. So I was getting this line here changing, and then these values here were flipping, but they were only flipping under very specific situations and circumstances. They only flipped whenever I tried to take my Bresenhams algorithm and put it into the subroutine. And the reason for them flipping, I still don't know. It goes through, whenever you're going through an intermediate command between pixels, if it's a pop command and I'm popping some value from the memory, it seems to interfere with this. But there's nothing physically happens. In order for this line to change here, I have to get a change here within this section or here. But none of these values actually change. So there's nothing changing, and I can actually see it real time. It just flips randomly without there being any input change. Now I have had this kind of thing before, and it tends to be something that kind of difficult to find, where there's 2 things changing at once and it gets confused. But I couldn't find what 2 things were changing at once, no matter how hard I tried to work it out. So, and it took me about a day just to find that this was actually, well, more than a day to find that this was actually the problem, because it's in the middle of a subroutine which is in the ROM, and it's quite a large piece of code, and it was hard for me to work out. It took me time to work out exactly where this problem was occurring. So even if I had, for example, a good debugger, it still wouldn't really have helped me very much, because it's actually a hardware issue or an issue with Logisim. So that was the first thing. Now, in order to fix that, I actually had to change the code a little bit. So I'll bring up the code just now. So this is the actual code here for, I'll make it the big, well, no, smaller. This is the actual code here for our Bresenhams algorithm, okay? And you can see here, it's the actual subroutine, okay? Now, in order to get the subroutine to work, there was a problem here with the pop color. Every time it did this command to pop the color, it would flip those that section within the graphics card. And as I say, I've still not worked out why it does it. But I had a workaround, and the workaround was, eventually I found a workaround which was relatively simple. Initially, we had the color was coming in the same as the values for our x1, y1, x2, y2. They were coming in, and they were getting into a memory location. Now, they were coming in via this ds command, so define storage, so it just defines one memory location, and it wouldn't work. So what I did was, I did the same thing, but rather than defining it as a define storage, I defined it as a define constant, which is a very similar thing. The only difference is it still defines or sets aside a memory location, but it puts an initial value into that memory location. So I put an initial value into that memory location of just this number here, which in effect still just gets written over, because I still go through the pop command and it pops the actual value that for the color that we choose from our line here. So it actually pops this value in here, and I've tried it, I've changed this value, and it will change the color fine. So it does take this value in. So that was the fix to get it working, and that's really the thing that's taken me about 3 days to work towards. Now, this doesn't happen very often. It's only a couple of times in the last 5-6 months in which I've been building the new CPU course that I've had these kind of issues, and they're really just down to, I think they're really down to Logisim, although there might be somewhere here where there's two things changing at once, but it would take me aeons to try and find out what that is. But anyway, that was one issue that I had, and it took me the longest time to work it out. Now, the second issue I had was my own fault, really, and it was quite a silly thing for me to do. But if I can find the code, I'll bring it up. So I have my code here for my assembler, and you see my assembler code is actually quite large now. Okay, so it's about 2,000 lines long, but of course there's lots of spaces in between, so maybe 1,500 lines. And it was a little kind of esoteric problem that I had, and I'll quickly describe it here. Whenever you set up a DC command, that's define constant command, all it really does is it just takes a number and it sticks it in a memory location. So in order to do that, it just generates a data command. So it goes data, the number, and then the memory location, and it just shuffles the number into a memory location. And all I do is I take those data commands and I just stick them at the top of the code. So the code's already been worked out, and all of the program counter values has already been worked out. And then all of a sudden I just say, well, okay, I've done that. Now I'm going to do this DC command, and I'll just stick this at the top. Now, it was a bit of an add-on because I wasn't originally going to do that DC command, but it was the quickest and easiest way I had of doing it. Really what I should have done is redone all of the code so that the DC command came in and it worked out the program counter values for each of those data values. But I never did that. I just added it in at the end as a block. And I was able to work out, adjust all of the jump positions for the labels and the memory location. So I just added a fixed number onto those. Okay, so I worked out the fixed number and added the fixed number on. But I had it somewhere in the code here. If I can bring it up, it's just some random little line here. I had it in the code, in fact it was here, that it was going to check this point here for this value 0 cross 8000. Okay, but 0 cross 8000 is assuming that the code is sitting in the RAM, but the real code isn't in the RAM, the code is sitting in the ROM. Okay, so rather than adjusting the values above that 0 cross 8000, I wanted to adjust the values above wherever the origin is. Okay, so I just changed that to origin. Okay, so it might not mean very much to you looking at this, but it just shows you that out of a 1,500 line piece of code, if there's just one tiny little bit out, then the whole thing is just falls apart. Okay, so it's quite complicated. So anyway, that with those two things done, I was then able to get the Bresenhams algorithm working as the subroutine. So I don't see any other quicker way for me to have worked that out. I just had to hammer it and just do as much as I can. I worked through as many different possible options as I could in order to figure out what was wrong with it. But that's it up, that's it working. I'll put the video onto the course, and it will be the last video really on that Design a CPU 2 course. And I'm hoping that this Bresenhams algorithm is the longest piece of code I've written, and I'm quite pleased that it actually works. I'm getting better at generating my own code here now. In the third course, we will continue with more of these algorithms, but a lot of them will be quite short. Okay, this was quite a long algorithm here, quite a complicated one for us to do, but it was a good one to finish off the course with. And now we've got it up and working, what I can do is I can generate a piece of code like this with like the line, but what I'll do is I'll generate the line within a loop, and I can draw lots of different lines of lots of different colours, lots of different start and end positions, and we could draw out a little picture or something. That's really it for this video. I'm starting to ramble on a bit. I'll get you on the next video. Goodbye.